All right. So, my name is Tatjana Svetova, and I'm an Android developer. And so my presentation title today is Make Your Android App Great Again by Using MVP Pattern. So what I want to share with you is the experience of myself and my colleagues on how we integrated this MVP pattern into already existing working live application. So I'm going to talk why we did it, how we did it, what were the results of our efforts, and whether we were satisfied with them or not. But first of all, let me give you some context of the story behind. So, like I said, I'm an Android developer. I work at a company called Rubylight, and Rubylight is in fact an investment fund which invests in growing startups with some kind of social interaction. So, for example, all kind of social networks. And additionally to financial investment, we also offer technical help because you see, quite often fast-growing startups are lacking in human resources or technology resources and experience, so we help them to build their team at first year. And so I've been lucky enough to work in one of such startups since January of this year, so almost a year, which is called Yodel. Yodel is a German startup. It is based in Berlin. It is location-based group chat. So, and it exists on both platforms, iOS and Android. So I joined the Android team in January. So, and this startup has been growing during this whole year with constant product development. We have releases almost every week, delivering new features and improvements and bug fixes, of course. Now, first, to give you the general impression of what Yodel application is from inside, let's see what we use in our application, what kind of libraries and approaches we use. First of all, there's OKHTTP and retrofit. We use them for talking with backend. So retrofit basically translates your JSON to Java and vice versa, and OKHTTP provides you connection to backend via HTTP protocol. Tell me if I'm going too fast. Now, we use reactive Java. I gotta be honest, not everywhere yet, and we're gradually adding it to our code because, like I said, I only joined. This application already existed before, since 2014, so it's a legacy code. Now we use Dagger for dependency injection. For those of you who don't know what Dagger is, it's a compile time dependency injection library. Basically, it just allows you to delegate the initialization of dependency to this library, and you only use the annotation for getting your dependencies. We use event bus auto implementation for some cases. We use Fresco from Facebook for downloading the images. We use the small little library Buttoneye for binding our views in layouts, and Mojito for testing. And finally, the Bitrise is our continuous integration. This is basically Jenkins with better UI, with more glamorous UI. And some other small libraries that I didn't want to mention here. Now, let me take you a few months back before we did any major architectural changes in the application. And I'm going to show you this a bit weird diagram. This is a basic structure of our application at that time. So for those who don't know the Android, the activity and fragments, those are the main UI elements, the actual screens that you see on your phone, sort of like containers for your layouts. Now, in Yodel, we had this main activity, which would create fragments and put them into backstack for display, and also fragments would create other fragments and also put them in backstack, and each fragment represented a separate part of functionality. And here we have all sorts of other parts of the application. Mostly of them are singletons. For example, storage is like a local storage, a wrapper around your shared preferences in Android. Yodel API is an interface for talking to backend. And we also had some kind of managers and like util, config, and etc. So to demonstrate you what these fragments represent, let's see some examples of the application. Now, first fragment, very rich fragment, I would say, this is a main feed. As any social network, Yodel also has a main feed where you see posts. And you can also change the sorting on the bottom. You can post from here, or you can go inside the post. The next one is channels fragment. The channel is sort of like subfeed. This is place when you can discuss one specific particular topic. So the name of a channel is this topic, and you enter it, you get into the subfeed. Now there's another quite important fragment or screen. It's a so-called me section, when user sees her posts, replies, and etc., her data. Now, and three more. This is the post details fragment, also quite busy with functionality. We have photo editing fragment. It seems simple, but there is a lot of logic behind it. And the so-called moderation fragment. We have users that are moderators. They receive flagged posts, and they can decide whether it should be blocked or not. Now, let's see. At that moment, a few months ago, before we did any changes, each fragment contained a lot of stuff, a lot of code, and did a lot of stuff. Yeah, you see the hint there. So first of all, it did the basic stuff, what it should do, inflating layouts, binding views, and setting up all sorts of listeners, implementing them. Then each of the fragments had a lot of, as I call it, if-elses, because we have this thing that when we deliver the feature or like some kind of improvement, we often use remote configuration in order to deliver the feature to, for example, a separate location, for example, just in Berlin. So there are a lot of checks in the code which decide whether to show something to people or not. Yeah, so each fragment would also work with the bus, posting events and subscribing to them and processing them. And finally, each fragment would hold reference to all those parts that I described before. Each fragment could reference to storage or to IP or to manager. And basically it was kind of messy, really messy, because managers would also talk to IP and request data and process it, and a fragment would contain both UI logic and business logic. So, you know, spaghetti code. Now, this approach led us to this one big question: how do we test it? Because you see, a few months back we didn't have a dedicated tester. Actually, she joined us like a couple months ago only. So the testing was done by product people and developers, which is not enough when you have a weekly release. And nobody actually had time or force to do the regression testing all the time. So we kind of wanted to cover this code that I mentioned before, the UI logic, the business logic, all sorts of logic, with tests, unit tests mostly. I'm not going to talk about UI testing yet, because the plain Java code, we thought plain Java code is supposed to be tested with unit tests rather than UI testing. So, and also, since this whole thing was kind of messy, we wanted to make it more clear and more manageable. So we had two tasks. First of all, change the structure, the architecture to better, to make it more clear and manageable. And the second one, to cover with test everything that's possible, everything that requires for it. So this is where the MVP pattern comes in, the one that's the topic of my presentation today. Now, I gotta say that MVP pattern is not a pattern for your whole application architecture. It's a pattern for your presentation layer only. This is a, yeah, I think it's an important point. Now, MVP stands for Model View Presenter. Model here is the one who handles business logic, who provides data for presenter, and who communicates with other layers such as database layer or network layer, for example. Now, view is what it is, the view. In our case, it's either activity or fragment. So I'm going to talk about fragments mostly. Now, view is supposed to be really simple and passive. And actually, doesn't really make any decisions. View only displays data and tells presenter about user actions, like notifies it. Presenter, on the other hand, is a plain Java object. It handles UI logic, it retrieves data from model, it tells View what to do, and presenter responds, like it processes the notification about user action from View. Now, the View and presenter are a couple. They are in a monogamous relationship. They have one-to-one relation. And since we want to keep presenter testable, because now it contains that UI logic that previously was in the View, we are using the interface for the View. So presenter holds a reference to View via the interface, and View holds a reference to presenter. So they live and die together, basically. And many developers stop at this point because they don't like too many interfaces. But we also use interface for presenter, because then you can put them both into one so-called contract interface, and it gives you the opportunity to actually see the interaction between those two at once. You don't have to dig into an implementation. You see at once who is responsible for what and what is their communication. Now, the last thing I want to say here is this weird arrow from model to presenter. I just put it there to show that model can send event bus events, and presenter can subscribe to them. So it's not direct communication, but there is some communication. All right. To show you the example how we did it in our application, I've chosen this feature because I was the one who was actually working with it. It's called channels. Like I said before, a person can follow channels and can get notifications about new posts in them, and user also sees some kind of suggestions that come from backend. There is some small search, so there is some kind of functionality behind it. So previously there was this one channel fragment, and additionally one adapter which was used for these two lists. Now we have this kind of structure. We have fragment, which is View, we have presenter, and we have model. The model is the last one, get channels. Now, I gotta mention there are two things, component and model. Those are the Dagger library things. I'm not gonna go into details because it's really like a separate topic for discussion. But we use Dagger for dependency injection here as well. Now, I'm gonna show you some code. I have simplified it from the actual application to just give you a general impression how it works. Now, first of all, we're gonna take a look at the model. It's really, really simple. It's just what it does. It provides the list, the map of channels that user is following. Now, it has interface and the implementation. The storage, as I said before, it's a local database, I can say. Like it's data, it's cache data saved on your phone. Now, the interface comes very handy because when you are developing new feature and you're waiting for backend to finish their implementation, you can just use the stub for this interface and continue with your view and presenter creation. Writing the code, basically. Now, this is the model in our case, and this is the contract that I mentioned before. So, we've got view and presenter interface. Now, view, I only put few methods here because in real life it's also quite big. As you can see, it only decides, like it only does what it's told to do, to show something, to hide something, to set data to some lists or not, or to set up listeners, for example, or show channel feed, meaning that when user clicks on the channel in the list, the actual channel feed will open. Okay. Now, presenter has first four methods are like they are shadowing the fragment lifecycle. If each fragment in Android has a lifecycle, and on create, view, and start, and resume, and stop, those are methods of the lifecycle. Now presenter will just take control from that point. We'll see later. And now here are examples of two methods, how presenter reacts to user actions. Now when user clicked on channel, the view will tell presenter now channel was clicked. Okay, let's go next. Now I'm going to show you the code. Don't be scared. Please don't hate me. Okay, and I'm going to try to explain it very simply. So first of all, we have this fragment now, and which implements view. So we have a reference to presenter, which is injected with dagger in our case. So now this is the basic stuff for, if you write with Android, you know that you have the reference to some kind of views from your layout. We have two views here and channel adapter for the recycle view here. This is just the beginning of the class. Now the onCreateView is the method from the lifecycle of fragment. Here we just inflating layout, binding the views, creating the adapter, and setting it to the channel view. Now here, I'm passing to the adapter the onClick listener. And the implementation of this onClick listener is just one line. Basically, it's just telling the presenter that the channel was clicked. So view does nothing. It just passes control to presenter. Now, there's some code that I removed for the simpleness. And in the end, we're also calling the presenter to tell him that, hey guy, this is the onCreateView. You can do your UI logic stuff now. Okay. These are three methods from the lifecycle of Fragment. Now, again, just to give you an example, that every time the control is passed to presenter here. And here comes the implementation of the interface view. The first one is setting channel. So as you see, no logic here, just setting some data to adapter. Also, no logic, just changing the visibility of the label. Here, only UI stuff happens. It just creates a new fragment, puts it into backstack. That's it. Now, no if-else's, nothing serious happening here. So this was the view. Now let's take a look at presenter, which again implements the presenter interface and holds references to, first of all, to the model, the get channels, then to a bus and the view via interface. And we're injecting it into constructor. Okay, so this is the example of the implementation on onCreateView. Now, when view called presenter decides, okay, I'm going to tell view to set up listeners, and then do some kind of inner logic. Now, on start, now presenter is the one who registers for the event bus events. Previously, it was the fragment. And on resume, you can put whatever UI logic you want there. I just removed it for the simpleness, and on stop, it unregisters from the bus. Okay, now here comes the implementation of the presenter interface now. This is presenter reacting on user clicking on a channel. It sends some kind of event outside and tells view to open the channel feed. Now, this is where the presenter handles the event bus and also does some logic. And this is the very simple example of the if-else that I mentioned before. This is basically what it's all about. This is the place where some kind of logic happens when a presenter decides whether to tell view this or that, and whether to display this and that. And it works with the model here. Okay, so very simple. Now, I want to tell the main steps that we did when we changed every feature, because like I said before, every fragment represented some separate part of functionality. So we went one by one to actually move it to MVP pattern. And with every feature, we did more or less the same. First of all, setting up the model. So we had this old fragment which contained that kind of spaghetti code. So first thing, we moved something that was related to model from that fragment to actual model. Second, we defined the view interface and presenter interface in a contract. When you have this old legacy code, you can actually go through it and see what kind of view methods you will need, or presenter method you will need, and you can already kind of create your structure, the contract. Now, the next step would be extracting logic from fragment now to presenter. So fragment is now a view. It only contains methods for displaying data or setting data or doing some kind of UI stuff. But the logic now is moved to presenter, the POJO, plain old Java object. And the last one, this is in our case, we had to set up dependencies with Dagger, the module, the component, those things that I showed before, so that it would work nicely all together. Now, again, let's go back to this very weird diagram. So this is how it was before then, like a few months ago, and this is how it sort of is now. So we have fragments as view now. We have presenters with each fragment because they are a couple. And we have model, which we call, in our case, use cases. And presenter can use more than one model, actually. And one model can be used by more than one presenter. So now the most important thing that we achieved here for us, that this part became testable finally. I mean, it was testable partially, but now we can actually cover with unit test everything that we wanted to cover it before. And yeah, but I should be honest that it's almost like this right now, because in fact we still are using references to those parts on the bottom in some presenters. So sometimes presenter still talks to the storage rather than to model. But we're going there, we're kind of moving everything outside, so the structure, the architecture would be more clear and manageable. All right. Now, again, I'm going to show you some code, but very simple and very easy. Just an example of how we actually were covering the presenter with unit test, in this case, channels presenter. So, this is, we're using Mahiri, as I mentioned before, so first of all, just initializing stuff. Now, the most important line here is that we can actually finally mock the view without using some kind of robolectic for mocking the fragment. Now we can actually just mock the interface here and test the presenter. So we're creating it, passing the mocks to it. Okay. If I'm going too fast this time. Now, this is very, I think, self-explanatory. We're just checking if presenter actually tells view what to do in this onCreate view method. That's it. And here we just testing whether presenter told the view to set the channels and to set the correct channels into this view, the list of channels. This is where we actually check whether the presenter told the view correctly that it should show no channels label. So we're testing that if-else that I previously mentioned. Very easy, I think. Now, yeah, and the last one, small test on whether presenter correctly sends the event after channel was clicked, and whether it correctly tells the view to open the channel feed. Right, so that's it. And small example to give you general impression. Now, this is a little bit of bragging. Since I was the one working with this channels feature and managed to cover this presenter 100% with unit test, but I need to maintain it all the time when new features appear in this part of the code. As for the rest of those fragments that I showed before, the situation a little bit worse, especially in this main feed fragment, which is our challenge still, but we're going there. There is too much of logic and code, and we're still writing unit tests when we have time for it. Okay, now shortly about this whole process of integration of what we did, converting every feature to MVP pattern. First of all, we did it very gradually because since we have weekly release, we really wanted to minimize the risk of creating new bugs in old feature. So we agreed that we would do it very gradually. We would change one feature at a time. with checking whether everything was fine. Now we used remotely configurable switches in order to keep the old implementation and the new implementation, so that we would be able remotely to turn on the new implementation, check if everything is working correctly and whether there were any crashes, and then if something went wrong, we would switch back to the old implementation. And the last one, we were watching our statistics and analytics in order to see whether everything was fine. I mean, we always do that, but in this case, we had to look for specific things and check whether the new implementation works fine. All right, now, this is the part where I'm gonna tell you whether we were satisfied with our results or not. We kind of were satisfied, because we did manage to fulfill the two tasks that I mentioned before. First, the structure, the architecture of application became better, more clear, more manageable. And secondly, we did cover, well, not completely covered with unit tests, but we did make it testable. The code that we wanted to be testable, we made it testable by applying this pattern. But additional to that, we also gained some kind of additional benefits here. Now, with the MVP pattern, we now received better code readability. It may seem a bit weird because there is definitely more code now, but in fact, there is better readability because we have a clear separation of responsibility. So you can, even like reading just the contract interface, you already get better understanding of what's going on inside this feature. It became a little bit easier to make changes because, again, it's all kind of separated from each other, and you always know where to go, where to look exactly to make certain changes. And yeah, unit test, well, that's, I guess, not additional benefit, that's the main benefit that we were going for. And the last one, it's kind of, maybe this is my personal opinion, but it does sort of disciplines you as a programmer because you are become a little bit limited to these rules and less prone to break those rules, because when you have spaghetti code, you kind of usually think, well, I'm going to add this more messy stuff here. Nobody will notice. Nothing will happen. Nothing. It can get worse than that. In this case, when you have this kind of nice, cute structure, you kind of will think twice or three times before you actually want to break the rule of this. Now, as for weaknesses, as Jared calls them, yeah, there's more code. So if you have the small application, not as big as Yodel, maybe it would be an overhead to use this kind of pattern. So yeah, but like I said, more code doesn't always mean bad, because you get maybe better readability with that, better navigation. And the second part, you have to get used to it, which means that you have to add a learning curve to your estimation. So when you're both developing new stuff and refactoring to this MVP pattern, you have to increase your estimation of development, because you have first to change your brains to use this pattern a little bit, sort of. And I guess that's it. I mean, I didn't find any bad about this pattern in the end. I mean, at least not in our case. Okay. And the last thing I want to mention that there is a nice little project in GitHub, which is called Google Samples Android Architecture, and it contains a few examples of this exactly MVP pattern with all kind of approaches, including the MVP dagger. I guess that's more, this is the one that we were basing our integration on. And I guess that's it. Do you have any questions?